The cathode ray tube flickers to life in the basement laboratory of Mitsubishi Heavy Industries, where Japan's most brilliant electronic engineers gather around equipment that was never supposed to exist. Captured Allied radar components, whose technological sophistication challenges every assumption about enemy capabilities, about Japanese electronic superiority, about the electromagnetic battlefield that has developed invisibly above Pacific skies, while Japanese night fighters attempt to defend the homeland against bombing raids they cannot see, cannot track, cannot intercept, through navigation systems that prove woefully inadequate against enemies whose technological advantages have rendered Japanese air defense virtually useless despite pilot courage and aircraft performance that should enable successful defense. Chief Engineer Kenji Yamamoto adjusts frequency controls on the captured radar unit with hands that tremble slightly from anticipation and dread, understanding that the oscilloscope traces emerging on the monitoring equipment will either confirm Japanese technological parity with Allied electronic warfare capabilities or reveal catastrophic gaps in radar development that explain the systematic failure of night fighter operations, the inability to locate enemy bomber formations until after they have completed their missions, the persistent reports from pilots who describe phantom contacts that disappear from visual range despite clear weather conditions and optimal visibility, the electromagnetic signatures that appear on the testing equipment, violate every principle of radar technology that Japanese engineering education emphasized through theoretical instruction based on German research, through practical application of magnetron developments that seemed adequate for detecting large aircraft formations at reasonable distances, through confident assumptions about technological superiority that characterized Japanese military planning until captured. Allied equipment began revealing innovations that Japanese scientists had not conceived, techniques that Japanese industry could not replicate, capabilities that Japanese military strategy had not anticipated or prepared to counter. Behind Yamamoto, a team of Japan's most experienced radar engineers observed the testing procedures, with growing recognition that their night fighter pilots have been flying missions against enemies equipped with electronic systems whose capabilities exceed Japanese understanding, whose performance characteristics enable tactical advantages that conventional aircraft interception cannot overcome, whose technological sophistication represents industrial and scientific achievements that Japanese research programs have not approached despite years of development effort and significant resource allocation to electronic warfare projects. This is October 1943. The Pacific War has entered a phase where technological superiority determines tactical outcomes more decisively than pilot skill or aircraft performance, where electronic warfare capabilities enable strategic advantages that conventional military planning cannot overcome through traditional approaches to air defense, where radar technology provides situational awareness that decides the difference between successful interception and catastrophic failure to locate enemy formations whose bombing missions threaten Japanese industrial capacity, civilian populations, military installations essential for continued resistance. The Allied night bombing campaigns have intensified beyond Japanese defensive capabilities through operational techniques that exploit electromagnetic advantages, navigation systems that enable precise target location under conditions that Japanese aircraft cannot operate effectively, coordination methods that concentrate attack power while dispersing defensive responses, tactical innovations that multiply individual bomber effectiveness through electronic systems whose capabilities Japanese military intelligence has failed to identify, analyze, or counter through appropriate technological development. Japanese night fighter operations reveal systematic failures that conventional tactical analysis cannot explain through pilot training deficiencies, aircraft performance limitations, operational coordination problems that typically account for defensive inefficiency, suggesting technological factors that Japanese military leaders have not recognized, electronic warfare dimensions that Japanese strategic planning has not incorporated, Capabilities gaps that captured Allied equipment might reveal through technical analysis that could expose fundamental inadequacies in Japanese radar development and electronic warfare preparation. The Nakajima J-1N Gecko night fighters that constitute Japan's primary defense against Allied bombing represent the pinnacle of Japanese aircraft design. Equipped with radar systems that Japanese engineers considered superior to enemy capabilities, armed with cannon that can destroy any bomber when properly positioned for attack, flown by pilots whose training includes specialized night-flying techniques that should enable successful interception under optimal conditions. Yet operational results indicate persistent failure to locate enemy formations despite apparent technological advantages. Pilot reports describe radar contacts that appear and disappear without explanation, navigation difficulties that prevent accurate interception despite clear weather conditions, communication problems that disrupt coordination between individual aircraft and ground control stations, creating operational confusion that eliminates tactical advantages while exposing night fighters to defensive fire from bomber formations whose positions Japanese pilots cannot maintain contact with through electronic systems that seem to malfunction consistently during critical engagement phases. The captured Allied radar components come from a downed B-29 Superfortress, whose electronic equipment survived impact sufficiently for technical analysis, whose radar systems represent American technological developments that Japanese intelligence services have attempted to understand through incomplete information. Fragmentary reports, theoretical speculation based on observed Allied operational capabilities rather than direct examination of actual equipment whose performance characteristics determine tactical effectiveness in electronic warfare environments. Yamamoto's initial examination of the Allied radar reveals construction techniques that Japanese manufacturing cannot replicate through existing industrial capabilities. Component specifications that require materials unavailable to Japanese military production. Circuit designs that demonstrate theoretical understanding of electromagnetic principles that Japanese research has not developed despite extensive investigation. Of radar technology applications for military purposes, indicating American electronic warfare advantages that extend beyond individual equipment performance to encompass systematic technological superiority. The frequency analysis reveals Allied radar operating characteristics that overlap with Japanese systems while providing performance capabilities that Japanese equipment cannot match through power output. Target resolution, range accuracy, environmental resistance that enables consistent operation under conditions that degrade Japanese radar effectiveness, suggesting American development of electronic warfare techniques that exploit specific weaknesses in Japanese radar technology while maintaining superior performance across broader operational parameters. More disturbing, the captured equipment reveals countermeasure capabilities that enable Allied aircraft to detect Japanese radar emissions, to analyze frequency characteristics, to implement jamming techniques that can disable Japanese radar systems while maintaining Allied electronic superiority, creating electromagnetic battlefield conditions where Japanese night fighters operate with severely compromised situational awareness, while Allied bombers maintain tactical advantages through superior electronic warfare capabilities that Japanese defensive planning never anticipated. The technical specifications indicate American radar technology that operates on frequency ranges Japanese systems cannot access, that provides target discrimination capabilities Japanese equipment cannot achieve, that maintains performance levels under jamming conditions that would disable Japanese radar completely, demonstrating technological gaps that explain Japanese night fighter operational failures while revealing American electronic warfare advantages that determine air superiority through technological dominance rather than tactical innovation or operational excellence. The power output measurements show Allied radar systems generating electromagnetic energy levels that Japanese magnetron technology cannot produce through existing tube designs, industrial manufacturing techniques, materials science applications that American research has advanced beyond Japanese capabilities, indicating fundamental differences in electronic warfare development that extend beyond individual component performance to encompass systematic technological advantages that enable Allied operational superiority in night combat environments. The circuit analysis reveals modulation techniques that Japanese engineers have not encountered in theoretical literature, frequency management systems that enable rapid adaptation to jamming attempts, signal processing capabilities that extract target information from electromagnetic environments where Japanese systems lose contact completely, demonstrating American development of electronic warfare technologies that Japanese research programs have not conceived through theoretical investigation or practical experimentation with radar applications. Dr. Hideaki Tanaka, Japan's leading radar specialist, examines the captured components with recognition that Allied technological capabilities exceed Japanese estimates by margins that invalidate fundamental assumptions about electromagnetic warfare balance, about technological parity between opposing forces, about Japanese ability to maintain competitive electronic warfare capabilities through incremental improvements to existing systems, rather than revolutionary advances that American research has apparently achieved through scientific breakthroughs. His analysis reveals American understanding of electromagnetic principles that Japanese theoretical research has not developed, application of materials science that Japanese industry cannot replicate, manufacturing techniques that produce electronic components whose performance characteristics exceed Japanese specifications by factors that suggest fundamental advances in electronic warfare technology rather than minor improvements to existing capabilities that Japanese development programs have pursued through conventional research approaches. The implications extend beyond radar technology to encompass broader questions about Japanese scientific capabilities, industrial capacity for advanced electronic warfare development, research methodology that may have overlooked critical theoretical principles, educational systems that may have failed to prepare Japanese engineers for technological competition against American scientific establishments whose resources, theoretical understanding, practical application capabilities apparently exceed Japanese estimates by significant margins. The captured radar's jamming resistance reveals Allied development of frequency hopping techniques that enable radar operation despite Japanese countermeasure attempts, spread spectrum technologies that maintain signal integrity under electromagnetic interference conditions, adaptive filtering systems that distinguish target returns from jamming signals, demonstrating American electronic warfare capabilities that render Japanese countermeasure techniques ineffective while maintaining Allied radar superiority through technological innovations rather than operational advantages. The range accuracy measurements indicate Allied radar systems that can maintain target tracking at distances where Japanese equipment loses contact, that provide navigation precision sufficient for night bombing operations under conditions where Japanese aircraft cannot maintain visual contact, that enable tactical coordination between multiple aircraft through data links that Japanese communication systems cannot intercept or jam effectively, creating Allied operational capabilities that Japanese defensive planning cannot counter through conventional tactical approaches. Testing of the Allied radar's target discrimination capabilities reveals resolution characteristics that enable identification of individual aircraft within formations that appear as single contacts on Japanese radar screens, altitude determination accuracy that supports precise interception calculations, velocity measurement precision that enables predictive targeting for anti-aircraft systems, providing Allied forces with situational awareness advantages that determine tactical outcomes through information superiority rather than equipment performance or pilot skill levels. The signal processing analysis reveals American development of computer-assisted target tracking that maintains contact through maneuvering, automatic threat identification systems that classify radar contacts according to aircraft type and threat priority, integrated display systems that present tactical information in formats that enhance pilot decision-making under combat stress, demonstrating Allied electronic warfare capabilities that Japanese technology cannot match through existing equipment or foreseeable development programs. The electromagnetic warfare implications become clear through analysis revealing Allied capability to operate radar systems that Japanese night fighters cannot detect until within visual range, that enable bomber navigation with precision that Japanese defensive measures cannot disrupt, that provide early warning of Japanese interceptor approach while maintaining Allied tactical advantages through superior situational awareness and electronic countermeasure capabilities that neutralize Japanese radar effectiveness. Captain Saburo Matsumoto, the night fighter squadron commander whose pilots have reported persistent difficulties with radar performance, observes the captured equipment testing with understanding that operational failures result from technological inadequacy rather than pilot error. Equipment malfunction, tactical inefficiency, providing explanation for systematic defensive failures that conventional analysis could not account for through traditional factors that determine air combat outcomes under normal operational conditions. His combat experience includes dozens of missions where Japanese radar systems lost contact with Allied bomber formations under circumstances that suggested equipment malfunction rather than enemy electronic warfare capabilities, where navigation systems failed to provide accurate positioning for interception attempts, where communication equipment experienced interference that prevented coordination between interceptor aircraft and ground control stations, creating operational conditions that eliminated Japanese tactical advantages. The revelation that Allied electronic warfare capabilities have systematically compromised Japanese night fighter effectiveness validates pilot reports that questioned equipment reliability, that described radar performance inconsistencies, that suggested enemy countermeasure capabilities beyond Japanese technological understanding, providing technical explanation for defensive failures that Japanese military leadership attributed to pilot inadequacy rather than technological disadvantage that captured Allied equipment now confirms. Through direct analysis, the strategic implications extend beyond night fighter operations to encompass broader Japanese air defense capabilities that depend on radar technology for early warning, target tracking, interceptor coordination, anti-aircraft fire control, demonstrating Allied electronic warfare advantages that compromise entire defensive systems rather than individual equipment performance, creating strategic vulnerabilities that conventional military planning cannot address through tactical modifications or operational improvements. General Takeshi Kawabe, commanding the Japanese Air Defense Forces, receives technical reports that reveal systematic technological disadvantages affecting all radar-dependent operations, that explain persistent failure to achieve effective defense against Allied bombing campaigns, that indicate American electronic warfare capabilities that enable strategic bombing effectiveness through technological superiority rather than tactical innovation or operational excellence, requiring fundamental reassessment of Japanese defensive capabilities and strategic planning assumptions. The military leadership's response to radar technology revelations includes emergency allocation of resources to reverse engineering programs that attempt to replicate Allied capabilities, acceleration of Japanese electronic warfare research that previously received lower priority than aircraft development, establishment of crash programs to develop countermeasures against Allied electronic warfare techniques that have compromised Japanese radar effectiveness throughout the Pacific theater. But the reverse engineering efforts revealed Japanese industrial limitations that prevent replication of Allied electronic components, materials science deficiencies that make reproduction of American radar technology impossible through existing manufacturing capabilities, theoretical gaps in electromagnetic understanding that require fundamental research before practical applications can be developed, indicating technological disadvantages that cannot be overcome through incremental improvements or conventional development programs. The materials analysis reveals Allied use of specialized alloys unavailable to Japanese industry. Vacuum tube technologies that Japanese manufacturing cannot replicate. Precision manufacturing techniques that require industrial capabilities beyond Japanese current capacity, demonstrating American technological advantages that result from superior industrial infrastructure rather than individual scientific breakthroughs that Japanese research might duplicate through theoretical investigation and experimental development. The theoretical investigation reveals American understanding of electromagnetic propagation principles that Japanese research has not discovered, signal processing mathematics that Japanese engineers have not developed, frequency management techniques that Japanese theoretical literature has not addressed, indicating fundamental gaps in scientific understanding that explain Japanese inability to develop competitive electronic warfare capabilities through existing research methodologies and educational systems. The industrial assessment reveals Japanese manufacturing limitations that prevent production of electronic components meeting Allied performance specifications, quality control deficiencies that would compromise radar reliability under combat conditions, resource constraints that limit development of advanced electronic warfare systems, demonstrating that technological gaps result from systematic disadvantages rather than specific deficiencies that targeted improvements might address effectively. The educational analysis reveals Japanese engineering training that emphasized mechanical rather than electronic systems, theoretical instruction that failed to address electromagnetic warfare applications, research methodology that prioritized incremental improvement over revolutionary innovation, indicating institutional factors that contributed to technological disadvantages that captured Allied equipment has revealed through direct comparison of actual capabilities. The time factor analysis reveals that developing competitive electronic warfare capabilities would require years of research, industrial development, educational reform that cannot be completed, while Allied bombing campaigns continue to exploit existing technological advantages, that American research programs will continue advancing while Japanese efforts attempt to achieve current Allied capability levels, creating dynamic technological competition that Japanese resources cannot win through conventional development approaches. The psychological impact on Japanese engineers includes recognition that American technological capabilities exceed Japanese estimates by margins that invalidate confident assumptions about technological parity, that Allied electronic warfare advantages result from systematic superiority rather than specific innovations that Japanese research might duplicate. The technological gaps determine strategic outcomes more decisively than tactical excellence or operational innovation that Japanese military planning emphasized. Post-war analysis reveals that captured Allied radar analysis marked the beginning of Japanese recognition that electronic warfare determined air superiority more decisively than aircraft performance. Pilot skill, tactical innovation, that American technological advantages resulted from superior scientific understanding, industrial capability, research methodology, rather than specific innovations that Japanese development might have matched through conventional approaches to electronic warfare research. The radar technology revelation influences Japanese post-war development of electronic systems that incorporate lessons learned from Allied technological superiority, that emphasize fundamental research rather than incremental improvement, that recognize electronic warfare as an essential component of modern military capability requiring systematic technological development rather than tactical adaptation to enemy capabilities that conventional military planning might address through operational modifications. Yamamoto continues electronic warfare research with understanding that technological superiority determines strategic outcomes in modern warfare, that scientific understanding must encompass revolutionary possibilities rather than incremental improvement, that international technological competition requires systematic capabilities rather than individual innovations that conventional research approaches might achieve through traditional development methodology. His research legacy influences Japanese electronic warfare development that recognizes captured enemy technology as essential intelligence source, that emphasizes reverse engineering as legitimate research methodology, that incorporates technological analysis into strategic planning, that balances current capabilities against enemy technological advantages requiring systematic response rather than tactical adaptation to immediate operational challenges. The captured radar components become foundation for Japanese understanding of American electronic warfare capabilities that determined Pacific air superiority, that revealed technological gaps affecting strategic planning, that demonstrated electromagnetic battlefield dimensions that Japanese military doctrine had not incorporated through conventional approaches to air defense, tactical planning, operational coordination that emphasized traditional factors over electronic warfare capabilities. Years later, when electronic warfare specialists analyze factors determining air superiority during Pacific operations, they cite Allied radar technology as decisive advantage that enabled strategic bombing effectiveness through electromagnetic dominance rather than aircraft performance, that demonstrated technological superiority as strategic weapon requiring systematic development rather than tactical innovation that conventional military planning might address through operational improvements. The laboratory discovery that revealed Japanese night fighter blindness becomes symbol of technological surprise, determining strategic outcomes, scientific understanding enabling military advantages that conventional planning cannot overcome, electronic warfare capabilities, creating battlefield dimensions that traditional military doctrine does not address through tactical approaches designed for previous technological environments. If stories like this remind you that technological assumptions can prove catastrophically wrong when confronted with enemy innovation, that captured technology reveals capabilities that intelligence estimates often miss, then perhaps there are other moments of technological revelation worth remembering, worth analyzing, worth carrying forward into whatever challenges require us to question comfortable assumptions about technological parity, to investigate enemy capabilities through direct analysis rather than theoretical speculation, to recognize that scientific understanding determines strategic outcomes in technological competition,